Let's go through the code for inserting a node into this doubly linked list. So the very first thing we do here in line 1 is we're just going to check and make sure that the position that was passed into this method is 0 or more. Just a little validation there. If it's wrong, then we'll just give an error message and then return out of the function. Uh, Line 2 creates our new node that we're going to insert into the linked list. So let's get that new node allocated. So here's that new node. Now, there's a couple of situations we need to cover. And the very first is what happens if the linked list is currently empty? That would mean that head is pointing to the null pointer. So that's what this section does right here. It handles that very case. If head is not valid, meaning it's pointing to the null pointer, well then, since we created this new node here, we will just assign new node and tail and head all to the same node. So tail will get assigned to new node. That was also previously pointing up to the null pointer. That's now going to point over to new node, and head is also now going to now point over to new node. And we've got a doubly linked list of one element now, and all three pointers are pointing to it. And then we'll also later in the code get rid of, no, we won't. We'll keep that pointer. Now, that's the case if the linked list is empty, and we're going to insert that node at the beginning. Now, there is later in our code, there is this instance right here, just to double check and make sure that the position passed in is still valid. Matter of fact, it checks and makes sure that the advancement of the pointer doesn't go past the linked list. And if that does, well, then we give them some kind of an error message. We will delete new node because we don't need to insert that anymore. And then we will just return and get out of that function. Then additionally, later in our code, we will cover the case where the insertion of the new node is at the tail. Now, after we take care of some of this housekeeping, first, if we are inserting at the head, let's just get that done, and then we're out of there. The rest of our code then handles insertion anywhere other than at the head. The first thing that we will do is create a new temporary pointer called temp, and temp is what's going to be used to traverse all the way through, and we're going to just go and count however many positions we need to go because we were given that integer as one of the parameters. Here's the situation now, then, if we have to insert somewhere other than the head. So what we're going to do is we had already created the, in line 2 up here, we had created the new node and called it new node. So I've got a pointer to that. I'll just call it N for now, but that means new node. And here is our new node ready to be inserted into the list in the correct position. And in this case, it's going to be after position number 1. So what we do here, we're going to create a node in line 3 here. We're going to create a node pointer called temp, and we're just going to point that to wherever head is. So we'll do that. Temp now is our pointer pointing to head. So what we'll do now is we will advance down the linked list, doubly linked list, in a for loop from 0 to position number of times. So if we want to insert it after the 0 element, then the for loop's not going to run at all. In this case, we'll insert it after the 1 element, so it's going to run at least one time. And it's also going to check and make sure that temp is always pointing to a valid node. So what this for loop is going to do here is just advance that pointer. And in this case, this pointer is going to then get redirected to right here. And at that point, the for loop is going to stop because we've gone position number of times. That would, of course, be longer if we were to have a longer linked list. So right now, we've got temp pointing right at the spot where we need to insert the new node right after it. Okay, now remember that just explained that this next code block here is just another quick guard just to make sure that pause didn't advance all the way to the end. And if it did, we'll just pop out of there with an error message. And by the way, then we'll delete new node because we created that in error. So the next part of our code then right here is all about the rewiring. We'll rewire these pointers to the correct nodes. It's that simple. So let's take a look at those. I'll do a different color here. The very first thing here, I'll call this in line 4, is that new node's next pointer, new node next, so that's the next pointer, whatever is coming out of there pointing forward, that's going to be assigned to temp next. So here's temp looking at element number 1, and the next pointer for temp next is actually pointing over here to old node 2. So since that's pointing there, this now is going to point there as well. Then in line 5, new node's previous is just going to be pointed to wherever temp is. So this previous is going to point to, here's temp going right here. So that is going to point to there. Now then, the only other thing that we need to rewire is the next element's previous. That now has got a point, and it's not this one here. It's this red one right here that we need to repipe. Right now it's pointing over to here, and we need to change that and get that to point over to here. So that's what this line 6 and 7 will do. It's checking real quick just to make sure that that we're not placing the new node at the end, because if we were, then there'd be no pointer to rewire. If it's the end, well, then the next pointer is pointing to the null pointer. So this is just checking those two cases. Is it at the very end, or is it somewhere before the end? So if it's somewhere before the end, then we're going to go to temp next prev. Now, isn't that a mouthful? So let's figure out, well, how does that actually happen? Well, here's temp right here. There's temp. Temp next is actually pointing right now over to here. And then temp next prev is actually pointing to here. And we want to change that to where it's now pointing to the new node. So we can actually have as many of these direction operators as we want. It's just going to keep referencing the correct one until it finds the one that we're referencing. And that pointer there is now going to then point to the new node right here. If it happens to be the tail, well, then we just set tail to the new node and we're done. And then as a very final step, what we do is say temp next. That's this one right here. That's the last one that has to be rewired, and that's going to get sent then to new node. So there are those pointers that just have to get redirected and pointed to the right spot, and the mechanism by which we get those pointed to the correct spots.